Hey guys, so last week we talked about the multiplication rule for independent events. So today we're going to look at the multiplication rule for dependent events and what that looks like. So make sure you complete this assignment and the one on Wednesday, because these will be your last two new assignments. And also if you did not complete the assignments from the past 2 weeks, make sure you go back and get those done, because that's the only way to get a 100 test grade. Okay, these daily grades don't have a whole lot of effect on your grade, but if you get that 100 test grade, that can help you out, especially if you're trying to move from a B to an A or a C to a B. That's really the only way to get that your grade moving a little bit. Okay, so dependent events are where one event occurs and that affects the probability of the other event occurring. Okay, so what you do on your first event is going to change something so that it affects the second event. Okay, so usually, and pretty much all of our problems are going to look like this today, you'll see the words without replacing or without replacement. That's how you know they're dependent. So if we want to find the probability of two dependent events, we're still going to multiply the probabilities together, but you have to assume that the first event has already occurred before completing the second event. So you kind of have to take into account what happened on that first event before you do the second event. Okay, so it can either look like this, probability of A and B, or probability of A intersect B, if you remember that symbol. And we're still multiplying the probabilities together. Okay, the first probability is not going to change, but we have to multiply it by the probability of B given, okay, if it's been a while since we've done that, that A has already occurred. Okay, so the formula is not, you don't have to memorize the formula or anything like that. We'll go through some examples and hopefully it'll make sense. It's not necessarily a specific thing you have to do here. It's more about thinking about it. Okay, so let's look at our 3 examples. We don't have a whole lot today. So a jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. A marble is chosen at random from the jar. A second marble is chosen without replacing the first one. Okay, so after you choose that first marble, then when you go to get the second one, okay, you've taken one away. So that's really how it's going to affect it. So what's the probability of choosing a green and then a yellow marble? So probability of green and then yellow. Okay, so the first one, it is basic probability. We need to know how many green out of how many total. Okay, so picking a green on the first draw, we would have 5 green out of 3 plus 5 is 8, plus 2 is 10, plus 6 is 16. Oops, sorry about that. Okay, so 5 out of the 16 are green. Okay, but it says when we change our second marble, it's chosen without replacing the first one. So when I draw that first one, we're going to assume that we drew what we wanted to draw. So we drew a green. So when I go to do my second draw, okay, I don't have 5 green in there. Now I only have 4. Okay, so now I'm going to multiply because we're still doing multiplication. But when I go to choose my yellow, now there's only 4 green left in the bag instead of 5 green. Okay, so yellow, we have 6 yellows. Okay, and now since we only have 4 green left, my total amount of marbles is going to change. So 3 plus 4 is 7, plus 2 is 9, plus 6 is 15. So this will decrease by 1 because we drew a marble out of the bag. Okay, and for all of these dependent events, you're going to see that happen. So that's really the big difference here, is this denominator is going to change on that second draw. Okay, and then we multiply. So 5 times 6 is 30. 16 times 15, you'll get some big numbers here, is 240. And then if you want to reduce that, you can. That would be 1 over 8. Make sure to do that right. Yeah. Okay, so if you have a calculator, you could obviously just type this in, but if you don't remember, you just multiply straight across. 5 times 6 and 16 times 15. All right, so a couple more, and you'll see how these all look pretty similar here. So an aquarium contains 6 male goldfish and 4 female goldfish. You randomly select a fish from the tank. Do not replace it. Okay, so that represents the dependent. then randomly select a second fish. What's the probability that both fish are male? So we're still drawing twice. Okay, this makes it compound. And we want to actually get a male on the first try and a male on the second try. Okay, because it says both of them need to be male. So our first one, we have 6 male out of 6 plus 4, so 10 goldfish. Okay, but when we go to draw our second one, this one's a little tricky because we actually want to draw the same thing both times. So remember, we want to assume that that first draw has happened and we got what we wanted to get. Okay, so if we drew a male on the first time, now I'm only going to have 5 males left the second time, and we didn't affect the female at all. Okay, so to get a male on the second draw, now there's only 5 males out of 5 plus 4 goldfish, so out of 9 goldfish. Okay, so that one actually affected the numerator and the denominator because you drew the same thing 2 times. Okay, and then we can multiply straight across. 6 times 5 is 30. 10 times 9 is 90. So 30 over 90, or 1/3. Okay, so if you see the same one twice, make sure you reduce that value as well. All right, and then the last one. So a basket contains 8 apples and 4 peaches. You randomly select a piece of fruit, eat it. Okay, so if you eat it, is it going back in the bowl? No. So you're taking that piece of fruit and it's gone then. And then you choose another piece of fruit. So what's the probability you select an apple and then a peach? Okay, so I've got that one written out for us. So probability of an apple on the first one. So we have 8 apples out of 12 pieces of fruit, 8 plus 4. Okay, but then we're going to eat that piece of fruit. So since we wanted an apple on the first draw, okay, that means I'm reducing the number of apples I have. And now to get a peach on the second draw, we have 4 peaches. And then my total has changed because I ate an apple from the first draw. So now I have only 7 apples and 4 peaches. So that gives me 11 total. Okay, so 8 times 4 is 32. I don't know why I just put that in my calculator. And 12 times 11 is 132. And then if you want to reduce that, 32 over 132 is 8 over 33. Okay, so just make sure that you account for what happened on the first draw. Okay, if you need to write them down and just kind of do what I did and cross out so you can make sure you get that right total. Okay, so those are the word problems. That's what most of your practice is going to be on. But then we have one other small detail here about testing to see if something is independent or dependent. So usually I gave you the word problem and we would just look through and see, okay, are you replacing it or not replacing it? But if you have probabilities, you can actually decide if 2 events are independent as well. If we're using that independent rule that we learned last week. So if we want to determine if 2 events are independent, we're going to substitute in what we know into this formula. Okay, and it can either say probability of A intersect B, or it can say probability of A and B. Okay, those mean the same. And we're going to multiply our 2 probabilities together and see if it equals, okay, what the other side equals. Okay, if it's equal, then the events are independent. Okay, you're basically saying, does this formula work? If it does, then the events are independent. If it's not equal, then they're not independent, or we can call them dependent. Okay, so it's really just multiplying these things together, and we want to see if it's actually equal to what it should be equal to. So not a lot of work, it's just multiplication. So M is taking a math class, S is taking a science class, then M and S is taking math and science class. So probability of math is 0.6, probability of science is 0.5, probability of math and science is 0.3. Okay, so math and science, okay, we know is 0.3. We want to know, does that equal the probability, the 2 individual probabilities multiplied together? So if I multiply 0.6 times 0.5, okay, am I going to get 0.3? And you should. So since those are equal, okay, this does equal 0.3, then we would say yes, they are independent. Okay, so you're basically just multiplying these two probabilities together. Oops, sorry about that. The two individual ones, the ones that do not say and. Okay, this one and this one. And you want to see if it equals this one. Okay, so most of the problems are going to look something like this where they just list them out. So probability of A is 0.5, probability of B is 0.25, and then if I multiply those together, it should equal this A intersect B, or A and B. Okay, so we just need to check. So if I do 0.5 times 0.25, okay, that gives me 0.125. Does that equal 0.3? No, it does not. So no, these are not independent. Okay, so you can either say they're not independent or you can call them dependent. Okay, so just multiply the two individual ones together, see if it equals that intersection or the and statement. So that's all you have to do on those. So don't overthink them. Just try to follow that rule and see if they're equal to each other or not. Okay, so let me know if you have any questions. Work on the quizzes assignment. You can redo it if you need to, so please do if you do not pass it. Okay.